Feel free. Okay, so we have some of the folks are on, and while probably more are joining, Gregory, if you'll bear with me, I'll go through a couple of some housekeeping notes. So welcome everyone to the third in a series of TransTech Boulder / Colorado webinars, all online so far. We hope to get together with folks in person soon. And we're excited about our special guest, about whom I will speak more later. For those of you who are new to TransTech, and I know some folks have heard about this call from the TransTech communications, some I think actually found us through Eventbrite, which flags these kinds of events with some of the keywords. And so those of you who are new to TransTech, here's a very short summary of what we're all about. And it is indeed a global community, Boulder being one of something like 50 different chapters, and truly international, Asia, Africa, Europe. We're entrepreneurs, like you'll hear from today. We're innovators, investors, technologists, all focused on building tech for mental wellness, emotional well-being, and human flourishing. So there's a list of technologies there. And we're going to hear about one novel use of computer vision today. So it's a very broad range of technologies that we try to focus on. And if you are indeed new to the organization, and especially if you're in the Boulder, Denver area, please do get in touch with me. We're still in the organizational phases, even though this is our third event. And we want to do a lot more than just events. And so you see some of that here. In particular, it's worth noting that the TransTech organization globally has an annual accelerator program that they run in September, and details are still forthcoming. But it's our ambition within the Colorado chapter to organize some participation in that event. Any entrepreneurs can elect to participate. It's a virtual accelerator program. But we thought it'd be a good idea to have the folks who are local to get to not only participate in the national program, but also be able to meet with each other locally, regionally, and share best practices and approaches. So we'll try to get an organizational meeting announcement out and plan to do that kind of a meeting in early July in anticipation of a sort of September start date. And then finally, every year there's a national conference which TransTech is best known for. And right now it's scheduled for November, likely to be a combination of some in person, but some online as well. And like everything, still in the works. And then happy to announce that we do have another webinar scheduled for 2 weeks out from here with Scott Brown, who is the CEO of Immersion, which is a relatively new startup using neuroscience for different kinds of predictive analytics. And they've got a range of applications. So pretty interesting, novel application of neuroscience. So that Eventbrite notice will go out later today. And so hopefully some of you can join us for that as well. All right, so with that, let me just check the, okay, so we've got a few more folks that have joined the call. Welcome everybody. I have everybody on mute, but you should be able to go off of mute if you need to. But let me introduce first our featured speaker, Gregory Menvielle, co-founder and CEO of Okaya. And Gregory, you're gonna have to do the pronunciations, the proper pronunciations of your name and of the company name and anything else I mess up here. But really interesting topic around computer vision and how that can contribute to mental health and well-being. Gregory is a French-American entrepreneur, 20 years of experience in IT consulting, international expansion. And as you can see here, his current focus is how do you use technology to put humans first. And then also keeps busy on the side with being part of the Intel Software Innovators Program for IoT and computer vision. So welcome, Gregory.
Thank you.
And let me stop my screen and see if you can go ahead.
All right, and thank you, Don. You're going to have to let me share the screen to give me control so I can share the screen for everybody. Meanwhile, hi everyone. As I mentioned, my name is Gregory Menvielle, and today we're going to be talking about how we use computer vision and other data points to help people live a better life and avoid burnout and fatigue. And I've seen that one of you just attended the TT meeting in Paris, so sorry, you're going to have to keep on hearing a bit of a French accent for a while for the presentation as it goes. All right, so let me make sure I can see my screen as well, which is always a fun part with Zoom.
We can see it on our side.
Perfect. So computer vision is coming a long way, and in my company, we're looking at using it to help people stay healthy. You're going to have access to my Twitter and to my email. The slides will be available, so if you need them, just drop me a line. You don't have to do screenshots like maniacs like right now. Just ask me and I'll be happy to share them with you. And obviously the call is being recorded as well, so we can have the merge of both. As Don mentioned, I'm part of the Intel Software Innovator Program in AI and IoT, which means that we often get to see early previews of what's happening or what has happened by now in different fields. And I'm also the co-founder of Okaya.me. And what Okaya does is very cool. We use computer vision, facial recognition, and other biometric analysis to help evaluate people's fatigue level and burnout. So we really are striving to help people lead better lives. And we're going to be talking about how computer vision works today. I'm going to show you a bit, explain to you a bit of how we do things. But before we start with everything that's going on, I want to make sure that throughout this presentation, we reinforce the concept of trust in the technology that we use. It's very, very important with everything that goes on to realize that technology by default is neutral. It's how we use it and how we implement it that makes it a good technology or a bad technology. And especially when it comes to the field all of us are in. We pretty much look at human data to give recommendations to human to help them improve. And it can be taken many ways. So just to reinforce this, for example, this is my one of my co-founders, Agnès Duverger, and yeah, we use her picture to help her realize how she's doing so she can avoid fatigue, burnouts, and help her companies operate better. That's great. Though let's all be cognizant of the fact that this very image could be used for other purposes and to prevent her from having access to certain things because of how she looks and how she's behaving. So for our talk today, the first part of the talk, I'm really gonna walk you through how computer vision currently works and some of the challenges with it. So to have a good understanding of where it stands and whether it's something you want to use in your daily life or not. Let's get started. So how do algorithms see? Even though it looks very cool on TV, it really comes down to math. And it's a pretty simple process. Now, if you're a specialist of computer vision, you may want to tune me off for a few minutes because I'm gonna go at a very low level explanation. Someone can get much deeper into it. But pretty much the way computer vision works, that you give it an image. So if it's a video, it's a series of frames within the image. And the computer is gonna start to look for features on that image. In our case, when we use facial recognition, we use that landmarks on the face, well over anywhere between 45 and 75 landmarks on that point. Then what the computer does, it looks at the features and it starts to classify you. And because it was trained, something that we will talk about later, it's going to decide which categories you fit in. That's the classical way of doing computer vision and machine learning. It's pretty fast, interesting way. Some of the newer technology that really helps refine how the analysis is being done is around what's called deep learning. And a very simple way of thinking of deep learning is that it repeats the same process many, many times, very, very quickly. So you still take the same image, you're still going to look at features, you're still going to classify those features. It just happens that you do much more of it, much more often. And advances in deep learning are interlinked to advances in computational power. Just to give you an idea, when we take a selfie video to track people's well-being, we take a 15-second video. Every second, we have anywhere between 30 to 60 frames. Those 30 to 60 frames, every time we look at about 75 points and then a bunch of other data sets. So as you can imagine, the amount of data that has to be processed becomes very quick, very big. And deep learning is only available because now we have enough cloud computing power to handle those things. So both models are available. And really the way it works, in the end, you give it a picture, the computer goes to work like crazy, look at the input layer, starts to do the analysis, and then eventually returns a result, whether the image that's being shown is that a cat or a dog. That's what you wanted to do. So that's really how computers look at things. Now, what can you see when you use computer vision, computer technology, whether it's an image or a video? Well, here are some examples. First, it's being used to identify people. And one thing that's very important to remember as well is like when a computer tells you whether, hey, you know, it's Don, it's Gregory, it's never going to give you a 100% match. It's going to give you, based on the algorithm, there is an X% chance that you're in this situation or not. And that's really something to keep in mind because it's never going to be able to tell you 100%. People identification, that's something that's used a lot. If you have an iPhone, you may even be using it, or Samsung now. You can be using it on a daily basis. It looks at the different points on your face and figures out whether it matches or not what it knows of you. So you can use it to identify people, give them access. An interesting field that we're seeing a lot of progress around is to identify gait and skeleton tracking. So within an interesting application we've seen within the COVID period, there are a few yoga studios that are starting to use this technology to make sure people have the right pose as they do yoga. That's an interesting use case. But obviously, as you start to track the body, there are many different ways and things you can do with this. And that's an interesting way to look at different problems. The computer will be looking at things that you may not be looking at. Now, the one that I'm sure you've heard of is to use it to start to scan people's temperature. That's the big hot topic, no pun intended, and we'll get back to it. But really, once you get to capturing certain biometrics, whether it's a temperature, heart rate, and it's really all show and tell. So those external cameras are actually 3D cameras. If you ever played with a Microsoft Kinect, or if you've seen kids play with Microsoft Kinect, that's the same kind of concept. You have infrared and 3D, and those cameras can pick up a lot of things. I've never played with a camera that takes temperature. This camera takes heart rate, and it's actually freakish to see that you can be on your home trainer with your heart rate monitor and the camera looking at you, and the results are fairly identical. So again, if you decide to track those things, computer vision can help you to track those things. Now, the question is, of course, can we trust the result? And that's when you get into some very, very tricky mode, and that's when understanding computer vision and how it works becomes handy. So remember, the computer is never going to tell you a yes, no answer. And this image is one of the more famous ones in computer vision because you're asking the computer to say, is that a cat or a dog? As you know, the algorithm responds dog. The trick is there's both a cat and a dog in the picture. So the little black thing on the bottom left is actually a cat that's curled up. Now, if you look at the actual algorithm, it would return a result saying dog 55%, cat 45%, because it's looking at all this information. But we have the tendency of taking whatever biggest result as the truth. So again, remember, if you're looking for just 100%, you would never be able to unlock your phone. And here, that's really the case. So yeah, that's the funny part. The computer got confused between a cat and a dog, but can it lead to some issues? Yes, because let's go back to the case about temperature. First of all, contrary to popular belief, most of the devices that are being deployed are not made to capture human temperatures. Some of them even have a range of plus or minus 5 degrees Fahrenheit, which would be enough to throw you into an at-risk zone or not. Also, remember, all that the camera does is report a data point. If I get heat stroke because I'm running outside and someone takes my temperature with that camera, I'm going to have the exact same temperature as someone who may be having a COVID issue. So just taking a data point just for the sake of taking a data point can become extremely risky. And that's something we need to be extremely aware of in our algorithm and when we do computer vision analysis. Now, here's another funny example, just to go a bit deeper into where the issues are coming from. Some people are constantly angry, i.e. me. So whenever I do computer vision, stare at the computer always sets me as angry. And my biggest problem, as you can tell, is that I have two huge wrinkles right here. And computers have been told, as we're going to be talking about in a second, they've been told that if you have those two big wrinkles here, it's a sign of anger. Doesn't mean that, you know, you're getting way too old, way too fast. No, that's a sign of anger. And the problem is with this, that once you start to know this, people start to compensate. So if I want to look happy in front of the computer, I really have to force it so much for it to register that I may probably gonna get a strain on my jaws or something at some point. One thing as well, you know, you always have to take things with a grain of salt. If I alternate back between the two pictures, you'll see that correctly identifies me as male, but then at one point decides I'm 46, the only time decides I'm 35 years old. And the truth is somewhere in between, closer to 46, unfortunately. But it's also interesting. Again, it's just reporting a point with likelihood of that point happening. And that's where most of the issues come with computer vision. Most of the discussions we're getting around computer vision, whether it's good or bad, is that people have the tendency of taking it as a very binary yes, no answer when an image and the result is presented, whereas the reality is much more granular. So why do we have this problem? Really comes down to bias. And bias, as we all know and should be aware of, is a huge problem in our society, and we're just translating it within the computer world, whether we like it or not. Now, for a computer to be able to understand things, at some point, someone has had to tell them what they were looking at. That's how a computer learns. So you take, like in this example, you take a bunch of images, and then you have people whose job is to literally draw the old polygons around an image and say, that's a cat, that's a dog, that's a backpack, that's a car. The more image you bring in, the bigger your data set. As you can imagine, you are extremely relying on people doing their job well 100% of the time. And then you're also you need to rely on bigger and bigger and bigger data sets to make proper evaluation. That's a cat and dog issue that we had before. So as we tag data, how we tag data then becomes an open door to creating bias in our algorithm and to creating a lot of problems. You know, going back to my anger system, because I'm tagged as angry, that may lead technically to someone being tired. We may be giving a false report about that person. So we have to be very careful. So you'd think that review and understanding data set and bias could help. Well, let me explain to you why it's a bit tricky. And for this, let's travel back to London, University College in the 1970s. St. George Hospital Med School was faced with a problem that's still very valid today. Tons of applicants, very little time for the faculty to decide who should get in and get out. So Dr. Franklin, he was one of the person teaching there, but also part of the admission process, thought that he could go and simplify the admission system. And he quickly realized, looking at the data, that every year about 2,000 attendees were just being turned down on the essays alone. So he started to work on simplifying how people analyze the essays, writing some algorithm around the data. And it was incredible, like 90 to 95% of the time, his algorithm matched what the review board would decide to do. It was astounding, quasi-miracle. So people started using it, but then very quickly they realized that there were some huge flaws in that algorithm for two reasons. First, there was let's call, you know, spade a spade. There was a huge amount of voluntary discrimination patterns in the way he built his algorithm, where already based on race or gender, the algorithm would eliminate people. Unfortunately, that's also how the committee was working when they were just reading the essays. So he just translated this. But there's a bit more of a perverse side that came into there, is that they used past data to figure out who the right fit was in terms of applicants. Now let's think about this. Med school, late 60s, early 70s in Europe. You can probably close your eyes for a second and you'll have a pretty good view of who the doctors or who the students were within that hospital and whom they had been since that hospital started 100 years back. So all the data set was already extremely biased towards certain genders, certain ethnicity, certain groups, certain location even. And that's when it became very interesting when computer scientists started to study the problem, how do you remove bias? Because say you want to have more diversity in your company. Say you want to have more, whatever the more is, wherever you want to reduce the bias, like how do you put this into a computer program without introducing other bias? Because no matter what, when we say we want more diversity, it's a very broad term. And as soon as you go into a computer just, again, thinks in terms of binary, zeros and one. You have to make decisions as to how you make your algorithm less biased. By doing so, no matter what, you're still going to be shutting people out, maybe in a new way. And when it becomes perverse is that then it spoils some of the other data you're going to use. So it's one of the classical case where you're already at the intersection of ethical and computer power. Because again, the algorithm will work very well. It's just going to follow what you told it to do. So how do we use all this and how do we solve all this when it looks into figuring out how tired and burnout people are? For us, we really rely on context. Now, let me tell you, yeah.
Hey, it's Don. Since we just had a question come in about the bias conversation.
Sure.
Do you want to take a question now?
Sure. Let's take a question now. It's a good time.
Yeah. So this is from Ismail. Humans are inherently biased. So could we hope to create, so you started going there, but could we hope to create in the future an AI that's not biased? How do you try to get there?
So let me answer this two ways. The first one is a bit of a joke where I recently saw a video from Neil deGrasse Tyson that had the similar question. And what he said is, unfortunately for us, maybe the moment the AI becomes smart enough to realize those things, he's not going to want us around anymore, realize how biased we are as a population. But more seriously, I do feel we have a duty within our field, whether it's trans tech and computer science, to be much more open as to how the data is collected and what the data sees, whether it's computer vision and other things. And I think that would be a very, very good first step to understand how we can reduce some of this bias. And also, there's a part at which we also have to be a bit clearer into what we try to achieve. Again, it goes back to when you say we want to be on AI that's more comprehensive, no matter what, the AI, as odd as it sounds, will have a bit of its own bias, no matter what. Because at some point, you have to make decisions. That's human nature, that's computer nature, if you think about it. Even a binary tree ends up making a decision. And when you make a decision, there's always some things you're not going to be happy with. And that's going to be very, I think the conversation is more around us being, what do we tolerate as to being unhappy with, as opposed to try to make everything match, which is very hard to do.
Great, thank you.
Okay. So, going back in our case at Okaya, one of the big reasons we're monitoring burnout and fatigue is really twofold. If you look at it just purely from the microcosm of COVID-19, what we're seeing is a huge increase in mental health issues and fewer people who can treat it. So our technology is really used by well-being professionals to do better triage and better follow-up on people's well-being. So if you want to go back to the business side, we're very much B2B. We're also working a lot with the universities and sports team, because then their notion of what the world was just changed, and it's a lot to cope and deal with. And then there's the last reality of it. Most of us nowadays are working from home, and you have poor HR managers who are totally at a loss as to how do they keep contact with their employees, how do they make sure their employees are doing well, because if the employees stop showing up for work, there's some huge consequences on the business side of it. So really our goal is to help organizations use this well-being data to make better choices and help people better. And to try to reduce bias as much as we can, or biggest approach is to try to use context in what we do. So as I mentioned, we start to do a 15-second video check-in, but we don't just do the video. When people take the video, they also speak. We also have an idea of where they're at. And then we look at a bunch of different landmarks to not only evaluate fatigue, but also to evaluate mood and other conditions. Now, because we merge this with external elements like the voice and location potentially and other piece of information, you can start to have a much bigger person of who the person is individually. And just because one marker is showing their fatigue, it may be because they just came back from a 2-hour run. So in how you report it and how people are going to treat it, you can then calibrate things a lot better. And we're finding these concepts of using different data points, different contextual information to report some information to be much more accurate than just going with one thing. So if we were just going to say, we're just going to take the video at the moment, you open the door to many, many issues. To give you a quick example coming from one of our therapist customers, usually if you go into a therapy session and you're sitting in front of the person you're interacting with, if they have their arm crossed like this, it pretty means that they're trying to, hold back. They have some issues they want to feel protected from. That's really fine. But one of the points that he made recently is that once you start to do that remote conversation, like the Zoom we're in, for example, you have no idea what the room temperature is when you're talking with that person. And that person may just be saying like this because they're freezing cold. And that happens more than you think. So that's why we're finding that bringing contextual information, not just relying on one data point, is one of the big differentiator between success and failure to identify different things. And then the idea is that as we start to follow the trend on how people are doing, then it's making it much easier for customers, the well-being professional, the HR, to make tangible and actionable recommendation for these people to get better much faster. So we started late 2018. We get some early funding in San Francisco, and since then we've been self-funded, working a lot with those people, and we've already learned some very interesting things too. How can you make it work? And I think because you're in the field of using transformative technology, some of the things we found you can use also in your business or in your approach to data. For us, one of the biggest win we have is that we're very clear that the end user own their data, their personal data. And that's really a big part because we're getting to a point now where customers are tired of being the product. I think people are finally realizing when you see all the problems happening with Facebook and Twitter and everything, you're just a pawn in the game and your data is being used for other means. So for us, by empowering our users to own the data, they feel a lot more safe and they open up a lot more. And also, technology should serve humans, not the other way around. When you look at measuring temperature or even measuring fatigue, whatever you're measuring, it's just a measurement. It's just an evaluation. In the end, a human should make a decision on how they want to act upon it. We cannot pass the buck to a machine to make the decision on what should be done with it. And within that idea of technology should serve to help human, that's something we've already noticed, is that oddly enough, we humans share a lot more with the machines than with other humans when it comes to collecting information. It's the classic, the waiter comes to you, are you enjoying your lunch? Oh, it's great, thank you. The minute you have to grade them on Yelp, it becomes a 1 out of 5 because there's something you didn't like. We don't like judgment, we don't like confrontation. We still feel that machines do not deliver those things. So one of the reasons we're using computer vision is that because people are much more open when they talk to the device than when they talk to other humans. However, the really interesting part is that humans believe other humans more when it comes to the treatment, to the action part. So if I go and tell Don, Don, you're using our tool, you're very tired. And if I give you a course of action on the app, he's much more likely to follow it than if it's actually a person giving him a course of action. A few other tricks, because I'm sure all of us want to avoid burnout and fatigue, especially if we've suffered that before. What we've seen in our data is like sleep is the great equalizer. And no matter what you think, you're not getting enough sleep. One thing that's very interesting, and going back to how humans perceive things and the reality of things, for example, in the realm of sleep, adults, not children for some odd reason, but adults have the tendency of over-reporting their sleep by close to 90 minutes. So, you know, if I were to ask all of you, how many hours did you sleep last night? Most likely you can take 90 minutes out, and that's the actual time you slept. And as you start to compute over time, that's a big problem. So my recommendation is sleep more and also read the book Why We Sleep. It's great. Other things also, because as you may be building your own transtech product, hoping to influence and transform how people think, a very interesting aspect of human behavior is that 50% of the time we do not follow recommendations, or we do not follow the recommendation entirely. And then people are wondering why they're not improving or not doing better. So it becomes very important to use different technology. And I know for us, that's something we've seen with our practitioners, to have that reinforcement. You're doing X, you're improving because you're doing X, keep doing X. And that's really key to help people transform and get better. And then the last part, there's always a level of gamification. Gamification, you may think of it just as a game. There are also so much more evil way to do gamification. For example, on your phone, when you have that little red dot with a message, with the one that starts to imprint on it, you know, on Facebook, Twitter, your email, that's part of gamification. The idea is that it's tricking you to click on it as quickly as you can. And gamification can be great to transform certain behavior and help people get better. What we've seen, however, is that more often than one, gamification quickly reinforces the wrong behavior or the wrong reason. Like, people are not doing it to improve, but in a sense to play the game or to appease things. And that's also part of what we're doing in our algorithm when it comes to computer vision and helping people avoid burnout, is try to get them to connect how their actions is having an influence on their condition, because we feel that's the best connection you can do to help people improve. Which also means that if you're an employer, and because trust me, a lot of companies are talking the talk right now, but very few are walking the walk. If you really care about your employees, all of a sudden you're going to be able to truly see which levers really impact their well-being on the long term. And just to say, hey, we're going to have a walking program next week. You may feel good about it, but that's a very good example of talking the talk and nothing behind it. So the minute you understand how action has consequences, and computer vision is great for this, the better a system you can build and recommend. So definitely let's turn this into a QA time. As a summary, computer vision works very, very well as long as you set the right expectation for yourself, for your company, and the outcome you want to follow. As Don mentioned, we're Boulder-based, and we're a small and growing startup. So we're always looking and interested in doing pilots. Right now, we're very interested in doing pilots within healthcare, and also for companies that just moved toward work from home, because those are the groups we can help the most. So if you guys have any connections here, we'll be very happy to hear about them. And finally, again, you can feel free to reach out to me if you have any questions, if you want the slides and or the recording. I'll be more than happy to share that with you as well. So with this, let's open this for two questions if you have any. And I will stop sharing the screen so I can also see what the questions are, which I can't do at the moment. Thank you.
Thank you, Gregory. Great stuff. We do have a couple of questions coming in. Laura Thomas, can you want to go off of mute and ask the question?
Oh, I was just the findings that Gregory was sharing on the last slide regarding like sleep and gamification not being skewing data. I was just wondering where, like, can you give more specifics on how that was found, or where?
Yeah, so as far, again, if you drop me a note, I can even send you some of the studies that were done in this. But it really came down to, people are feeling it really comes down to psychology and how people approach interaction with others. And some of the way they studied it, for example, you take a test subject, you give them some questions on a form to write. You ask them for, then you have this same kind of question in front of a person, and then a computer asks similar questions again, and the results differ. And again, most of the findings is that it has to do with perception and fear of judgment.
Thank you.
One question I see.
I would like to see your study.
Yeah, definitely drop me a note. I'll send you the links. Rick, you mentioned how behavioral economics suggests it's no such thing as truly neutral environment, and you're 100% right. Actually, my background is in econ originally, and there are a lot of behavioral economics issues that are being followed with this. True, things are not balanced and neutral to start, and I think the more you share, as you said, is that the more you share how you use the data, the more then you can start to get back to that neutral environment, because you have more information and how people react differently to different things. So, but again, behavioral economics as well was also developed in a way to understand why people took certain actions. So I do agree with you. Everything is biased at the end. The outcome is often followed by how people would like the outcome to be, unfortunately.
Yeah, and I just encourage folks who are particularly looking to create applications that are effective in this field, really get linked with somebody who understands a lot of the behavioral economics techniques, because there's some terrific ways to really engage and shape behaviors in a really effective way. I did want to offer up a slightly different point of view on something you said right at the beginning, where you talked about technology is neutral. It's just about how you use it.
Mm-hmm.
We spend a lot of time with the startups that we deal with talking about this from a slightly different perspective. And the perspective isn't mine. It actually comes from a French cultural theorist who said, when you invent the ship, you also invent the shipwreck. When you invent the plane, you invent the plane crash. Every technology carries its own negativity, which is invented at the same time as the progress.
Mm-hmm.
And so we spend a lot of time with our startups, particularly in this field, talking about the fact that they need to own both sides of this and think very hard about the capabilities they're building and the potential for misuse or use in ways that would be incredibly counterproductive to the things they're actually trying to achieve.
Yeah. Oh, absolutely spot on. So two things, just to finish on the behavioral economic side, I think two things are good. There's a book named Hooked, which is very interesting to do those things. And then I really enjoyed the writings and thinking of Rory Sutherland, who is, he used to be one of the lead person at Ogilvy Marketing in London, but he does a lot of thinking around behavioral economics, which is very, very interesting. Now, as to your point, I think you and I are looking at the situation exactly the same way, where you're building something. It can be used for good or evil, in a sense, based on how people use it. If we want to take a bit more of a lighthearted approach. But what's extremely key is exactly what you said. People need to own that what they're building can be used either way, and also to be able to understand that they should have safeguards in place on any other way, because you never know how people are going to be using different things. Shipwrecked, rockets enters one ground, it started in a very bad way, ended up, taking us to the moon. So we need to understand the perimeter of what we're doing and how it can impact people. Absolutely agree with you.
So let me jump on that, because Rick brought up the point that made me think of computer vision generally has its dark side, right? Which is surveillance and privacy issues. So I noticed on your website you have a privacy policy, which just kind of comes with. But if I understand your business model is partly reaching out directly to employers to implement in their company, how does the communication happen there to assure people it's for this reason only?
So there are a few things that we're doing. First of all, when we work with the company, we have, if you can call that a chart or an engagement, so how the data is used and being used. That's step one. But then we're also very cognizant that employees, understandably enough, for some reason, can be leery of their employers. So what we've done that's pretty cool is that we have a kind of a double trust system where you as the employee can go and see whomever has viewed your data. So, if you think of LinkedIn, you can see who has viewed your profile. However, they try to obfuscate that at times to get you to pay more. Here it's a different theory. Because you're the data, you do it. Other things we found is that actually employees, because we're in between as a buffer, view it much more as a safe zone than when the employer comes to you and say, hey, here's the employee survey for the year. Can you please fill it out? And people do not fill things out as thoroughly. That's something we've found as well. Now, the last part, Also, because we recognize there's some areas where the trust is not there between an employee and an employer. We're also targeting certain markets where employees know that sharing their well-being information also has a big impact on their health and results. For example, for nursing and doctors, no one wants to have the responsibility of having a lawsuit because they were not in shape to do a surgery, for example, or they were not ready to do things. And what we're finding there, it no longer becomes an issue of are people good or not good to do work, but much more, how can we adapt the work environment to make sure that our team performs at its best? And once you start to change the conversation from one aspect to the other, that's when it becomes very intriguing. But again, to go back to Rick's point earlier on, we were very aware of how the negative side of things and how it can be used in a negative way. And that's why we try to avoid it as much as possible.
Great.
So George, question about feedback loop. I don't know if you can unmute yourself, George, if you want to elaborate.
Oh yeah, I'm here now.
Hi.
You know, I've been fascinated by how we can use technology to improve our well-being since I went to this workshop years ago. God, in the 90s, we used GSR on our shoulders to measure the tension in our shoulders. And it would be like every time I type, it would go off. And it was so hard to practice typing without it. And then afterwards, I noticed, oh, every time I type, I tense up a little bit. And when you mentioned that the angriest man, it's like, oh my goodness, I have that too. Like that, you know, what is it when, and it's not like you're really angry, but there's something that's just a little tight. But at the same time, here you're measuring something that goes a little beyond that, perhaps like, you know, that's more indicative of burnout. But for the argument's sake, you've established, like maybe you do find these things that are good markers in a person. How do you present that to someone in such a way that it can help them in a way that adds to their life rather than takes away? You know, like the shoulder thing, like you couldn't do that while you're working. Like you can train, but when you're working, you're like, get the fuck out of here. I have a deadline. Like I want to just get on with it. And in life, when something is giving you feedback, like maybe you turn the spell checker off on Word till you're done with the document. But what are the ways that you've thought about structuring the feedback loops between the individuals, the care practitioners, and the others so that people can win? And maybe that's behavioral economics. I mean, there might be another domain too to that as well.
Yes, and I think you're putting things exactly in the way it is. There's the, let's call this the evaluation part. That's where computer vision, that's when the device you talk about, that's when all those things come into place. What they do, they just return a number as to how you're doing. Then how you use that number to improve people's life, that's when it becomes interesting. So I grew up in France, went to Catholic school where, you know, we were just beat into submission, into admitting we're stupid, which is one approach. And we don't buy into this approach. We're finding that positive reinforcement and helping people transform for the best is the goal. Now, here's where it gets back in how we do things in our example. So I've taken my video, I get the results, I get the trend. We don't just give you a score. The score really is going to be a mix between what you say, how you look, and your environment. And at times we're going to be asking people, you know, what do you do? What kind of activities do you do? What are you doing? And the idea is to get people to associate the good behaviors with improving their well-being or lowering how tired they are. Once you start to do this, that's when people start to make change, positive change. And also that's how people go back to doing positive change as things start to drop. Because let's face it, we're never moving up all the time, one direction. It's a series of ebb and flows, and that's really where it becomes key. And that's a behavioral economy. That's hope. That's gamification. It's to reinforce this behavior so people keep on doing it. You know, just like it's like raising a kid. You know, in a sense, if you keep on harping the bad things on them, they turn negative. They shut down. They don't do things anymore. But if you keep on reinforcing what they've done positively, they're going to feed on this to improve everything. What we do with computer vision the same way is just now we're able to quantify and show that to you that your positive efforts is having an impact.
Thank you.
You're welcome. Mobio Interactive, question about tech. What are the most exciting developments in CV for well-being quantification emerging now or on the horizon? So And obviously we're pretty excited with some of the work we're doing, but also when I mentioned the skeleton tracking, I think it opens the door to many, many interesting applications, especially now that we're going to be in an age where it's going to be harder to see practitioners, and it's going to be harder right now because we're in a confinement period of very limited, but we're also starting to see, think of cases where people are going to change their behavior and their way of life. You know, with work from home, you may be further away from the people you used to see to get your treatment. And the minute you start to lose that third dimension interaction with people, it becomes a lot harder to diagnose you on a regular basis. So anything around skeleton tracking, I think is going to be very, very interesting. And it's going to go way beyond the yoga poses. I think it's going to be used in a good way. Other examples that I've seen that are pretty exciting about is that when it comes to water treatment, you can do a lot of, there's some companies doing some extremely cool work around water analysis, just using external 3D cameras, and they're getting some very good results. So that can help many communities in many different locations. So those are some examples that come to mind.
So you're saying water treatment?
Yeah. So technically,
you have a camera to detect particles or something?
Yeah, so you have this kind of cameras, really, and they use that 3D to start to detect particles. And they're doing some really interesting findings around it. There's some, it goes back to the pros and cons. I think within cities, the way they can be used to monitor and improve traffic and other information can be done, but it's not as transformative. It's something that has been done for a long time. So lots of cool things that we're seeing on the horizon.
I ask a question about the detection of the facial features,
yeah,
and their correlation to emotional states. Very easy to fake a smile and a frown and trick a computer, right? I mean, very, very easy, right? So
yeah.
what is being developed in order to detect authenticity of facial expression?
Yeah, so obviously it depends on what kind of application you want to have. If you take just a base model, pretty much you're just building a toy around it, because as you said, things can be faked. The approach that we're taking, and we're seeing other companies in other fields kind of take a similar approach, is look at the whole context. Because if you can also use voice and the environment, you can start, it's harder to fake many points at the same time than it is to just one. So that's one part that's being used a lot. And also that's also part where it goes back to improving algorithm, looking at the data and tagging it properly, because how different things are being faked is going to look different. So someone can force themselves to smile like this, it's still not going to look natural because of the points, because of the muscles that are being used. So people are also refining the algorithm itself to start to see when it's a fake or when it's a plausible thing.
So you would actually have a tag for a true smile versus fake smile.
You can you can use this. One of the emotion that comes back often that we're saying, you have a tag for sadness, for example. And what we're seeing is that oftentimes the markers for sadness are initiated by the same muscles as tiredness. So one could mean the other, vice versa. Same thing. One of the common human emotion is surprise. But surprise can be both a negative and a positive. And so people are also doing a lot of research into looking into which muscles are activated to have these different kind of tags, as you mentioned.
Cool, okay.
So I had a question kind of following from that, is a more general one about skill sets in your company. So, the AI piece, obviously is a big chunk of this, but between staff and advisors, how are you building your company to, what kinds of skills are you looking for and needing?
Sure. Well, again, keep in mind, we're not a funded company. So my answer may disappoint you in terms of breadth of people we hire. We cannot hire 50
where
people.
Where would you like to be? I guess is the question.
No, it's a reality of things. So right now we're very good on the computer vision side of things, because one of our co-founder has been working in that field for 15 to 20 years now. Study his work is in area in Europe. On the product side, Agnes has a lot of experience, just like myself, when it comes to product and gamification. So those things are in. And we just got invited to submit an NSF grant, so we'll see where that goes as well. Our goal as a company is to do those things seriously. You know, to go back to Rick's point, is really understanding the good part and the bad part of how the algorithm can be used and become very good on the technology side. So we're always looking for machine learning specialists and data scientist specialists. One thing that you'll very seldom hear me say is the word AI, because I think, especially if you work enough in the field, you know that AI will not exist for many, many years. So it comes down to machine learning in some way, shape, or form. So that's one thing we're looking at. And then at the same time, yeah, if we could ramp up on the sales side, right now we're also doing a lot of sales via partners. That's the way to grow. So those would be the two first key skills we'd be able to hire.
Cool. Thanks. Any other questions, folks? Come off mute if you're trying to ask.
Maybe I could
Sure.
ask another one.
Yep.
In terms of your business strategy, are you considering providing other providers with maybe an SDK or an API so that they can leverage your technology and plug it into their own digital therapeutics or offering?
Yes, we're already in very advanced talks with a few companies where they have their product, and in a sense we can add more information to what they do so they can build a better product as a result. So absolutely.
One more, since I'm here in Boulder,
Sure.
and you're nearby, is you were a little dismissive of yoga there. I mean, come on. You know, this is Boulder. There's a huge market.
Yeah, it is a huge market. Yeah, we're all in Boulder. We'll do our yoga. I was, you know, what we're all joking aside, what we're finding is that oftentimes those really long-term transformative technologies start in very small niches to answer the proverbial one need, which at the time, right now, it's an issue. If you take a yoga class, you're not having the right pose, you can really mess up your back. And that's a lot of talking to that company that does the detection. That's something they've heard a lot. And you know, you mess your back, it's your yogi's fault. You stop seeing those guys. So we're really seeing technology right now try to support the business in a sense. People are not used to working remote or interacting with customers remote. You know, computer vision, it can also give you like one scary example, but in the way that we're helping some of our customers. When it comes down to therapists or people interacting with students, now they're interacting remote. Now, I'm talking with you, Don, but I have no idea who is next to you or who is around you or who can hear me speak within the same room. For most of us, we don't think about it. When it comes to students, it actually breaks their rights that they have if you start to divulge information that other people can hear. We've also seen a huge increase in domestic violence for similar reasons. People talk or cannot talk as freely because of the environment they're in. And that's where, you know, some of our technology is used to facilitate those things. But that's when you really have to realize how much our environment is changing as it goes.
Great. Thoughtful answer.
In that arena, it's interesting because I've got a friend who's a therapist who does a lot of work with children, and she's had to move all of her stuff to Zoom. And she said it's been actually incredibly helpful. She relates it back to the old days where doctors did house calls, and you could actually see the environment that your patient was in and the effect it might be having on their health. She's seeing the same thing with these kids, that seeing them set up in their bedrooms and how they're set up and organized and the things on their shelves have added a whole nother layer of information to the data gathering process she has with these kids. So for her, you know, having to do all these things remotely has actually helped her in some ways.
Yeah. Oh, solely. And just to reinforce what I was saying, we're doing some work right now with someone who does a lot of PTSD treatment. And, you know, it used to be that they had to evaluate whether that person was suicidal, how suicidal they were, and all this information. But being able to see their surroundings outside of the meeting itself becomes a huge asset to help treat those people better.
Great. Okay, one last question, anybody? If not, Thank you, Gregory, so
All
much.
right. Well, thank you, everyone.
Yeah, thank you very
Great
much. This was
presentation.
great.
Yeah, thanks
Thank
everybody
you.
for participation. Good engagement. And we look forward to seeing more of Okaya in the future. Great.
Thank you.
Thanks, everybody.
Thank you.